Hello students, in today's video we are going to see about network address translation for IP version 4. So why we have to go for a network address translation? We all know that IP version 4 addresses are 32-bit numbers. Mathematically, this means that you will have more than 4 billion unique IP version 4 address. But however, that address is not enough to manage the devices that is growing on. So now we have NAT is designed to help manage those 4 billion addresses so that we can all use our many devices to access the internet. So some of the NAT characteristics that we have here are, so networks are commonly implemented using private IP version 4 address. So in an IP version 4, you have two types of address. One is the public address, the other one is the private address. So the private address ranges are given as below, like in class A, we have 10.0.0.0 to 10.255.255.255. Similarly, in class B, we have 172.16.0.0 to 172.31.255.255. And in class C also, we have 192.168.0.0 to 192.168.255.255. So these are the some of the private IP addresses. So this private IP addresses are used within the organization. So outside an organization, these IP addresses are not routable. And now if you see here, this NAT, as we discussed earlier, this NAT helps to manage the IP version 4 depletion. So without NAT, the IP version 4 would have already depleted by 2000. Still, we could see that some of the devices are operating using IP version 4. That is because of this capability called NAT. So imagine here you have a very big organization. So within an organization, we will use the private addresses. And outside the organization, there is something called the public IP addresses. And there is a router called the NAT router or the gateway router that translates your private IP into a public IP, right? So now what are the types of NAT? How actually this translation is done? Everything we'll see in the coming slides. So let's say that here is a private network and the network has 10.1.1.0/30 for this WAN network and 192.168 for this local area network. Now, what happens is there is a router called R2. So you call this as a stub network. Stub network means this is only one exit available for any packets to go outside. Okay, so if any network has one exit point, you call it as a stub network. So now when it comes to the NAT enabled border router, this router translates this private IP into a public IP. It also maintains something called a NAT translation table. So now it has to maintain a private IP. So imagine that 192.168.10.10 is sending a message to 209.165.201.8. So there should be an IP address for this. So let it be 8.8.8.8. Okay. Now in the NAT table, it maintains so 192.168.10.10. Okay, and its public IP is 8.8.8.8 and its destination is this server. So there is a table maintained in the NAT router. So when the reply comes, the reply obviously will come from 209.165.201. So it refers the NAT table. So here is where the destination address. So this is the reply that I have received from 209.165. So how should I translate? So I should translate it to 10.10. So again, the other side of translation takes place when the packet comes inside. So there is a translation when a packet goes outside, that is your private IP is converted into a public IP. And when a packet comes in, the public IP is converted into a private IP and it is delivered to the destination. So this is what happens in a NAT. So there are few terminologies that we have to be very familiar with when we use a NAT. Number one is the inside address. So what is an inside address? The address of the device which is being translated by the NAT. So here, this is the inside address. 192.168.10.10 is the inside address. And there is also something called local address. So the local address is any address that appears on the inside portion of the network. So inside a network, you have any network. So inside address, you call it as a local address. Similarly, outside address, the address of the destination device, right? So the destination device is to whom are we communicating? right? So here you see that 209.165.201.1. And similarly, the global address is any address that appears on the outside portion of the network. So here I told you 8.8.8.8. So that appears to be the global address. Okay, that is the global address for this network. So there can be any number of users this side. So this side of your network, there can be any number of users. But for the outside internet, it seems that there is only one single user, that is 8.8.8.8. So let us see with this example. Here you have 192.168.10.10 and here you have 209.165.200.226. All right. So now when a packet goes outside, this is called inside local and the outside local is this IP address. Okay. So this router's exit IP address. So it is 209.165.201.1. And then inside global is how that packet is getting translated. Okay, so that packet is actually that packet is getting translated as 209.165.200 or 226. So that is the address of this. Okay, this is the address which is given here. Okay, then outside global is 209.165.201.1, which is the web server's address. So this is outside global and outside local also has this IP address. Okay, so inside global is this IP address and inside local is this IP address. Okay, and when it comes to the reverse side, again, it is translated. So once this translation is done, it is also maintained in the NAT table. So what are the types of NAT? One is a static NAT. So static NAT is one-to-one mapping, right? So static NAT is particularly useful for web servers or devices that must have a consistent address. Okay, so such as the company's web server, always it should be move out with only one IP addresses. So here the static NAT, see this table, 10.10 is always translated as 209.165.200.226. Similarly, 10.11 is always translated as 200 or 227 and 10.12 is always translated as 200 or 228. Right? So this is an example of a static NAT. Then it is a dynamic NAT. So dynamic NAT will have a range of IP addresses. Okay, so here you have 226 to 230 is the range. And whenever the first packet comes out, this router assigns the first available address. And all the other addresses are assigned. And then when the second packet comes, the second available address is assigned. Okay, so this is how the NAT router will assign for this. All right. And then the third one is port address translation. So port address translation, PAT, it is also known as NAT overload. We call it as a NAT overload. Okay. So now it is similar to that of a NAT where multiple private IP addresses are mapped to a single public IP addresses. All right. So the IP assigns one address to the router, yet several members of the household can simultaneously access the internet. So this is most common form of NAT for both the home and the enterprises. So now actually how the port address translation is done is, so let us take this example. Okay, so you say 192.168.10.10. Okay, and the application has a port number of 1,555. And then it is going to access the web server outside 201.1 and the web server's well-known port number is 80. So this is how when it comes to the router, okay, the router, this is how. And similarly, let us take the other example. There is one more person who is using the port number 1331. Again, it is destined for 202.129.80. Okay. Now what happens is both of them are going to get translated into a single public IP address because it has to be translated to this public IP addresses, which is nothing but 209.165.200.226. That is a single IP that is given to this place. So now how it is translated is, it is translated this way, 209.165.200.226 and the port number is accompanying that particular message. Okay, so and similarly 209.165.200.226 with a different port number. So this is called port address translation. So even though two different entities, they are translated into a single public IP, but those entities are indicated by means of the port numbers. Okay. Now let's take the other case. It goes to the destination and the destination generates a message. Okay, when it comes to the router will check this routing table. Okay, so it is coming as source port. The destination port is 209.160 202 120 180, and the source is to a single person. Okay, now it will check the port number. So 1331. So 1331 is translated. Okay, this is the IP which is translated. So let me put the packet to this host. Similarly, 1555. So now it will check its routing table. So 1555 is nothing but this one. So let me put the packet to here. Okay, so this is how the port address translation is done. So there may be some packets which is not using layer 4. Okay, so that do not contain a layer 4 port number. So in that case, how actually it is done? The most common case is ICMP version 4, which we used to have ping. Okay, we used to do ping. That is an example of ICMP. So what they usually have is they have something called query ID, right? So instead of port number, the query ID is inserted, okay, in the request, and the reply also comes. It is matched to the query ID, and then the reply is rerouted to the appropriate destination. Okay, so what is the advantages of NAT? So it conserves the public IP. For example, here you have an organization, you use 192 series, okay, 192 series. And however, when it comes to the internet, it is known as 8.8.8.8. Okay, so here is a global internet, and there can be another organization which again uses 192 series inside. And again, the public IP that is 9.9.9.9. Okay, so outside world, this full, maybe here I have 10,000 plus users. So this 10,000 plus users are known only by 9.9.9.9. So there is a reuse of the IP address between this network and this network. So you conserve the public IP addresses. Then it enhances the security, right? So because the internal IP addresses are hidden. Okay, so for the external people, or for the hacker who is in the internet is unaware of these 10,000 plus users, and there is a less chance or less ground for the attack. And then it allows a private IP reuse. As I told you in the previous slide, there is a reuse, and seamless network expansion is possible. And also it enables the internet connectivity without the exhaustion of IP version 4. There are also some disadvantages of NAT. Okay, so complicates the network configuration because you have to really configure a router for the translation. There should be a NAT table maintained. Okay, and it also really will not give a feel of a real peer-to-peer application. Okay, so when you just try to configure a peer-to-peer application between a host inside the local area network, okay, so and maybe between another local area network. So this doesn't seem exactly like a P2P network. So there is also an increase in the latency because of the translation, and there is a break in the end-to-end connectivity, and it is not suitable for IP version 6. Even though NAT 6 is available, it is not suitable for IP version 6. So now we'll see the packet tracer configuration of static NAT, dynamic NAT, and PAT.